Hello friends, how are you? I hope all of you are doing well. Let us continue with limits where we left off. Last exercise we started with exercise 13.1. So today we're going to just do some more questions from 13.1. So today basically we will be doing emphasizing more on just to find out whether a limit exists or not. So if you remember last class we discussed and we studied about how to say when a limit exists. Only when the left hand limit and the right hand limit approaches towards the same particular value, then we say that a limit exists. Otherwise, the limiting value for that function when x approaches a particular value is said to not exist if from the left hand and from the right hand side are approaching different values. So we will be studying questions. So there are some important, not important, but there are some like good questions which I'll be doing in the last part of the exercise. So please watch the full video, and then of course please do not forget to bring your pen, paper and books also. So this is basically for class 11 science. Alright, so the first question that I'll be doing here today is question number 24, that is limiting value of the function. Find out the limit of the function f of x as x tends to 1 where the function is defined for us given. That is x square minus 1 when the value of x is less than or equal to 1, and minus x square minus 1 when the value of x square is greater than 1. So see, this is how we recognize using functions also. That means whenever the value of x will be greater than 1, you will be using this function, and whenever the value of x is less than or equal to 1, you will be using this function. So let's find out the left hand limit. That is the left hand limit. That is going to be, what is the value of the function, limiting value of the function as x tends to 1 from the left hand side, as x approaches 1 from the left hand side. From the left hand side. So that will be, what we do is, as we did in the previous exercise, we change the interval. So from the left hand side, that means slightly less than 1. So please do watch the previous video if you haven't watched, otherwise you will not be understanding what is happening here. So now, that's what I mean here. So as h tends to 0. So now when I say 1 minus h, where h is a very small interval. So when I say 1 minus h, it means that we're talking about a value that is slightly less than x. That is slightly less than 1. Sorry, slightly less than 1. So if you look at this value, this function that is given to us, which is the function that we are supposed to choose whenever the value of x is slightly less than 1. So the value of x which we are supposed to choose when the value of x is slightly less than 1 is what? X square minus 1. So that is going to be x square minus 1. X square minus 1. But we know that our variable is not, the function is not in terms of x, the function is in terms of 1 minus h. So only that we will be replacing 1 minus h. So now if we just solve this as h tends to 0, so that if we expand 1 minus, I'll just remove the bracket, 1 minus 2h plus h square minus 1. After expanding and just remove the bracket, expanded this minus 1. So now 1, 1 done. So then what we have is limiting value of minus 2h plus h square as h tends to 0. So then I think we can easily substitute the value of h because we are not getting 0 by 0. So if I just substitute here, I'll have minus 2 into 0 plus 0 squared. So that, of course, what is it going to be? It is going to be, of course, 0. Right. So that's the left hand limit. So the value of the left hand limit that we have here is 0. Alright. Let's see what happens. So what happens with the value from the right hand side. So let's see. For the right hand limit, nothing much. As x approaches 1 from the right hand side, so that's going to be h slightly greater than 1 for x. So now when it is slightly greater than 1, which function are we going to use? We are actually supposed to use this function, that is minus of h squared. Now what is x here? 1 plus h. So minus of 1 plus h whole square. So we just expand this also. Then what will we have here? 1 a plus b whole square, 2h plus h square minus 1. So there will be a slight change definitely. So if we just solve this, so that's going to be limit as h tends to 0, minus 1 minus 2h minus h square minus 1. So I'm going to rub this off. So that will be limit as h tends to 0 for the function minus 2h minus h squared. So then I can just substitute the value of h. So that's going to be minus 2 minus 0 squared, that is 0. So what do we have here? Minus 2. Now if you remember, the left hand limit that we had calculated was from the left hand side, it was approaching 0. Whereas here from the right hand side, it is approaching what? Minus 2. So now it is clear that even though the question says find out the value of the function as the limit as x approaches 1, we see that from the left hand limit and the right hand limit are not approaching towards the same particular value. One is approaching towards 0, one is approaching towards minus 2. So it's clear that the limit does not exist. So we cannot find out the value of the function as the limiting value of the function as x tends to 1. So of course we can write, since limiting value for the function as x tends to 1 from the left hand side is not equal to the limiting value of the function as x approaches 1 from the right hand side, limit of the function as x tends to 1 does not exist. That means like left hand limit, right hand limit combines together to give us the value of the limit. So it does not exist. Okay, so fine, that's done. Let's move on to the other question, that is like maybe one more question that alright, so maybe we can do number 26, question number 26. Let's see what we have here. 26, that says find out the limiting value for the function f as x tends to 0, where our function is given by x upon mode of x, that is modulus of x, as x is not equal to 0, as x is equal to 0. That means whenever x is equal to 0, x, we will use the value of the function as 0. When x is not equal to 0, x by mod of x. Now let's see what we have here. So let's try to find out quickly, that is left hand limit. It's going to be limit of the function x tends to 0 minus f of x. So that's going to be as h tends to 0, change the interval, f of 0 minus h. 0 minus means slightly less than 0. So definitely it's going to be 0 minus h, a smaller interval. So that will be, I'll just write it again, 0 minus h is minus h. So then it says whenever x is not equal to 0, so x is not equal to 0 here, isn't it? Because x is slightly less than 0, because it's 0 minus h, so slightly less than 0. So our function will be x by mod x. But what is the variable here? It's going to be minus h. So that's limit as h tends to 0 minus h by mod of minus h. So that will be limit minus h. As we have already studied for the modulus function in the previous videos, minus of mod h will be h. So now here, before you really put h equal to 0, which is not possible, but it can be simplified because this value is minus 1. Minus h minus 1. So now, no matter what the value of h is, it is not going to affect the value of minus 1. So minus 1 will remain minus 1. So that's our left hand limit. Okay, so that is our left hand limit. Now let's see what happens to the function as we approach 0 from the right hand side. So that's slightly greater than 0. So slightly greater than 0. So 0 plus h is going to be plus h. So same function we are going to be using, because when it says when x is not equal to 0. But of course it's going to be plus h plus h. So that's going to be h divided by h. So that's here plus 1. Simple math. Plus 1. So again, here also the same problem, that is the left hand limit approaches is minus 1, the right hand limit is plus 1. So here also what do we have to conclude? That this one actually does not exist. Even if you're telling us to find out that, it actually does not exist. So the same conclusion, of course, you can write, that is so the same conclusion we can write, that is right hand or left hand limit is not equal to right hand. Since I wrote here right hand, it's not equal to left hand limit. So limiting value of the function as x tends to 0 does not exist. So that's how it is going to be. That's how going to be our conclusion. So next, maybe we can try 29. That's an interesting question. Let's see what we have there with 29. I hope you have your textbook there, so let me not write that big question for all of us. So now that question 29, it says like, let a1, a2, a3 and up to an be fixed real numbers. Okay, so they are just real numbers, constant numbers. And define a function. So our function here is given as x minus a1, x minus a2 dot goes till x minus an. So this is our function. Now the question is, what is the limiting value of the function f of x as x tends to a1? So never go for the looks. Okay, never go for the looks. That's why there is a saying which says like, never judge a book by its cover. Never judge a book by its cover. So that applies to everyone. Never judge a person by what somebody tells you how he is. We should know that person, then only we should judge. So without reading a book, just by looking at its cover, we cannot actually say that whether that book is really good or not. And all of us, we have different taste. So certain books we will like, certain books, the same books which I like, you may not like it. So we should always see for ourselves and then only judge. So that's what I mean here with this question also. So this question also, okay, looks a bit, it's a bit different than the other questions, but look at the question carefully. It's a very simple question. That is, if a1, a2 and an are just, what do we call it, real numbers, and the function is defined to you. The only question that they ask is, what is the limiting value of the function f of x as x tends to a1? So that is going to be limiting value as x tends to a1, the function. What is my function here? X minus a1, x minus a2 dot x minus an. So definitely I'm not getting 0 by 0, so I can just substitute the value of x as a1. So that's going to be a1 minus a1, a1 minus a2, just replacing the value of x. It will continue x a1 minus an. So it's very clear, because here this first value a1 minus a is 0. So 0 into the product of any number, that is just what? 0. Simple as that. That's why I say never go for the looks or never judge anyone just by what somebody tells you. Okay, we should always know. So you see, as we have tried, it's very simple. That's it. Alright, that's fine. What is the next question? Also for some a, definitely for some value of a, keeping in mind that a is not equal to any one of the values. That is, it's not equal to a1, that means a1 and a are not same, that is a is a different value compared to a1, a2 and an. Compute the value of the function at x tends to a, as x tends to a. Now as x tends to a for the same function, that will be done in the same way, as x tends to a, as x tends to a. So that's it, we can't do anything there, so that is going to be our value as x tends to a. But that is our answer here, as x tends to a. Yes, what did you expect? You expected some big, difficult questions, solutions. No, that's all that we have to do here, simple as that. Alright, okay. Alright, let's move on to some other question again. Alright, let's try 31. Now question number 31 states, if the function satisfies this limiting value as x tends to 1, f of x minus 2, x squared minus 1 is equal to pi. They are telling us to evaluate limiting value of the function as x tends to 1. Alright, this is also not a difficult question. Now we also know that the quotient part for the limits that I gave you on fundamental theorems of limits. So this function the limiting value of this entire function can be simply written as limit as x tends to 1 f of x minus 2. Maybe I'll just write it in bracket, this function. Limit x tends to 1 x squared minus 1. It's equal to what? Pi. Now with the help of this knowledge, we just have to find out limiting value of the function as x tends to 1. So we don't have to do anything different here. We'll just take advantage of the equation or the function that is given to us. Alright, simple as that. Now, again, from fundamental theorem of limits, we can also write limiting value of the function f of x. I'll just write limiting value for 2 as x tends to 1, as x tends to 1 whole divided by. Okay, here maybe I can just put the value, no, not now. Here also, maybe what I'll do here is, I'll just cross multiply it on the other side. So that's going to be pi into limiting value as x tends to 1, x squared minus 1. Alright, so then, this is what we are supposed to find out. So let's leave it as it is. Let's limit of x tends to 1 minus, as I say, as x changes, 2 is not going to change. 2 will remain 2. Pi into, I can just substitute the value of x here, use the value of the limit, x tends to 1, so that's 1 squared minus 1. So that's going to be okay, maybe one more step. X minus 2 equal to, this is pi into 0. So that's going to be 0. So limiting value as x tends to 1 for the function will be, this is already 0. So minus 2, I just bring it to the other side. So what is the answer here? That is going to be definitely what? Plus 2. So that was also not a difficult question at all, isn't it? Remember, pi into 0, of course, this is going to be what? 0. So I'll just bring this 2 on the other side, it becomes plus 2. So limiting value, that is what the question asks. Like, find out the value of limiting value of this function as x tends to 1. So it is what? 2. By simple mathematical calculations and taking advantage of the equation that is being given to us. Okay, so maybe one more question that we can try, that is like 32. Now a function is given to us. That's going to be m x squared plus n x plus m x cubed plus m. When x is less than 0, use this function. When x is greater than or equal to 0, less than or equal to 1, use this function. And when x is greater than 1, use this function. Alright. Now the question is, for what integers of m and n, does both the function, first one is limiting value of the function as x tends to 0, and the other one is limiting value for the function as x tends to 1, exist. For what values of m and n? It does exist. Now let's see, let's check it out. So for it to exist, let's go for the first point, that is as x tends to 0. So for it to exist, the left hand and the right hand limits should be same. So let's see what we really need to do. So that is going to be limiting value as x tends to 0, left hand limit. That will be limit h tends to 0, f of 0 minus h. So that is limit h tends to 0, f of minus h. So for minus h, that is 0, approaching 0 from the left hand side, that is slightly less than 0. So whenever x is less than 0, we are supposed to use this function. So limit h tends to 0, m minus h squared plus n. So that will be limit h tends to 0. So that's okay. Now we can just use. So h is equal to 0. If we just use, this becomes m into 0 plus n. So okay, what do we have here? The left hand limit that we have here is n. Alright, let's check the right hand limit. I'll just take the advantage of this function only. So if we go for the right hand limit, so let's not forget the left hand limit that we have here is n. Okay, when you go for the right hand limit, 0 plus, so that's going to be plus h as h tends to 0. So only here only the function may change. That is when it is greater than 0, we use n into h plus m. So a slight change, that is going to be n into 0 plus m. So what do we have here? M. So that means our right hand limit is m and left hand limit is n. Now the question that is being asked to us is, what should be the values of m and n? What should be the values of m and n for the limiting value of the function as x tends to 0 to exist? Now for this to exist, what should happen is, see, for limiting value of the function as x tends to 0 to exist, we should have what? Limiting value as x tends to 0, the left hand limit, equal to what? The right hand limit. That means n should be equal to m. That means only when n is equal to m, the limiting value of the function as x tends to 0 will exist. So that's what the question means. Let's go to the second point, that is as x tends to, we are supposed to check for as x tends to 1. Alright, so as x tends to 1. So let's find out quickly, as x tends to 1, what happens? So, alright, so limiting value for the function, as x tends to 1 from the left hand side. So that is limit, in changing the interval, 1 minus h, so limit h tends to 0. 1 minus h means less than 1. Less than 1, it has to be nx plus m. So that is nx plus m. So that will be limit as h tends to 0. No, I can just substitute now. I can just substitute n into 1 minus 0 plus m. So that I have n plus m. Alright. So this is my left hand limit. So let's not forget that our left hand limit is n plus m. Okay, left hand limit. Let's not forget that. Let's go for the right hand limit. Now right hand limit, that is approaching 1 from the right hand side, that is 1 plus h, slightly greater than x. So definitely our function changes, greater than 1, that is n into x, our variable is 1 plus h, cube into m. Let's see what we can do here. That is, maybe we'll have to expand. That's always better to simplify. So that is n, a plus b whole cube formula, that is a cube plus 3a square b plus 3ab square plus b cube plus m. Alright, I hope all of us, we know what is a plus b whole cube, isn't it? At least in this class 11 standard. So now, okay, maybe we can just put in the value of, sorry, this is only for n, not for m. Alright, now let's put in the value of h equal to 0. So we have n, 1 plus 0 plus 0 plus 0 plus m, because as h is 0, this term 0, 0, 0. So what do we have? N into, okay, one more time, n into 1 plus m. So that is what? N plus m. So now, what do we have here? What is our right hand limit? Right hand limit is n plus m. What was our left hand limit? Left hand limit was also n plus m. So that means this is already equal actually, isn't it? Unlike the other first part, first question, where it had to be, it would exist only when n would be equal to m. But here, the terms are already same, m plus n, m plus n. That is, since limit as x tends to 1 from the left hand side is equal to limit as x tends to 1 plus, both are equal to n plus m. So here, for every real value of n and m, limiting value of the function as x tends to 1 will exist. Simple as that. For the first part, n had to be equal to m, but for this, it's already saying that means for every real values of n and m, the function will definitely exist. So that's what we are basically supposed to be doing in this particular exercise. So that's like that somehow winds up the limit section for this year NBSE syllabus, because some of the part of the exponential and logarithmic limits have been reduced as per the syllabus. You can go and check out my video on the revised syllabus for 2020 due to the pandemics, and then you can, so next topic we will be moving on to differentiation. So that's a very interesting topic and a very, very important topic. So please, maybe I'll be bringing out the video very, very soon. So fine then, that's all. So I hope all of you are keeping safe. If you have liked this video, please do like, share, and please don't forget to subscribe so that you will get definitely regular notifications. And it would be good if you can hit the bell icon also. That will give you regular updates on every new video that is being uploaded. So till then, take care. See you very soon in the next video.